All right, arc length and sector area. Here we go. What's the distance around a whole circle called? The circumference. Circumference is equal to what? 2 pi r. 2 pi r. So if the radius is 4, the circumference would be 2 times pi times 4, or 8 pi. But what if I didn't want the whole circumference? What if I wanted just the section from A to B? What if I wanted to know this distance from A to B? Well, if I know my central angle, let's say my central angle is 90 degrees, then I can use what formula we used back in geometry. 90 degrees out of how many degrees are there in a circle? 360 degrees times the circumference of 2 times pi times 4. Okay, that'll give me the arc length. So it's 1/4 of 8 pi, which is 2 pi. So the arc length here is 2 pi. That's how long that is if the circle has a radius of 4. Let's do another one. Here's a circle. Okay, arc AC is 110 degrees. The radius is 6. I want to know what the arc length of arc ABC is. What's the arc length of arc ABC? The long way around. All right, so arc length is S. Why they use S? I don't know. But arc length is S. So S is equal to however many degrees we have out of 360 times 2 pi r. Well, in this case, what would X be for arc ABC? 250. Because if we use 110 of it here, what's left is 250 out of the 360 degrees times 2 pi times 6. Well, what happens here is 250 over 360 is 25 over 36. Divide them both by 10. 2 times 6 is 12. So I have 25 over 36 times 12 pi. Well, I know 12 goes into 36 how many times? 3 times. 1 and 3. So my answer is 25 pi over 3. Okay, arc length. But not all the time will you be given our angle in degrees. In trig class, we deal with angles in radians. So let's say our radius is 12 and our angle is pi over 4 radians. Okay. When we're dealing with trig and arc length, the formula changes to something actually easier. S equals my central angle times the radius. It equals the central angle times the radius. So our arc length here is just pi over 4 times 12 in this case. So what's pi over 4 times 12? No. I don't care about the stupid calculator. How many pi is that? 3 pi. Because 12 over 4 is 3. So it's 3 pi. Now, if it tells you to put it into a decimal, round it to so many places, you do that. But most of the time, we want these in terms of pi. Okay? All right. Arc length. Okay, fairly easy to understand. Next concept. Sector area. So let's say I have some pie and I ate a piece of pie. Now I cut this pie into 6 pieces. Okay, so each pie piece is 60 degrees. If I use a 12-inch pie pan, then it has a 6-inch radius. Okay, how many square inches of pie did I eat? If I ate a piece that's a 60-degree slice of pie, that is 6 inches in radius. Okay. Sector area in geometry is just the part of the area, so it's the angle over 360 times pi r squared. This is the percent of the area. So in this case, I take 60 over 360 times pi r squared. 60 over 360 is 6 over 36, or 1/6, times 6 squared is 36 pi. What's 1/6 of 36? So it's 6 pi. I ate 6 pi square inches, or 37 or so square inches of pie if I ate that piece of pie. Speaking about pieces of pie, March 14th, what do we know about March 14th? It's Pi Day. So that's when we get extra credit. Except for, I think Pi Day is on spring break. So we'll have to do Pi Day before spring break. Okay? All right. So sector area. You just take the part of the circle times the area of the circle, and you're good. Now, let's say the circle has an angle in terms of radians, like 7 pi over 4 radians. Okay? 7 pi over 4 radians. And you want to find this area, and you have a radius of 16. Okay? So when you're dealing with sector area and trig, area, when you're in radians, is our central angle times the radius squared, all divided by 2. The central angle times the radius squared, all divided by 2. So you take 7 pi over 4 times 16 squared, all over 2. Well, 16 squared is 256. I know 4 goes into 256. 64 times. And I know 2 goes into 64 32 times. So I just take 32 times 7, which is 224 pi. That's the area of that sector. Okay? That's the area of that sector. So that's sector area for you. Okay? So, I let go too soon. Okay, there's the planet Earth. Here's Madison. Now, Madison is approximately 46 degrees south of the North Pole. Now, if the radius of the Earth is 2,512 miles, and Santa Claus has to fly his sled to your house in Madison, and he goes on the surface of the Earth, so maybe he just skates right along the surface of the Earth. How many miles does Santa Claus travel to get to your house to deliver you presents? Okay. Are we dealing with arc length or sector area? Arc length. Okay. Length of that arc. Since we have degrees involved, are we doing geometry or trig? Geometry. So we put the angle 46 over 360 times 2 pi times the radius. Now this time, I'll say, what is it to the nearest mile? If I ask you to the nearest mile, what should you do with your pi? Put it into your calculator. So you take 46 divided by 360 times 2 times pi times 2512. Round it to the nearest mile, please, and see how far Santa Claus traveled. Everybody agree? Okay. Do you need to see any more examples or you want to get started? All right, let's get started on our first assignment. I will put it out there. Just give me a second.